Boa tarde. Vamos então dar início a esta sessão. Eu vou mudar para inglês porque o nosso speaker, José Luís Martínez, is from Spanish and is the CTO of Capside. José has a long experience in cloud infrastructure and he will present us a session, The Adventure of Being a Site Reliability Engineer.
Yes. Hello? Okay, you hear me? Okay. Great. As Raquel said, I'm Luís Martínez, CTO of Capside, a company that recently was acquired by NTT. And I'm here to talk about, we basically architect, build, and then maintain infrastructure for our customers in a 24/7 fashion, so our customers can focus on delivering value to customers while we take care about their infrastructure. And so we're basically SREs. And what does SRE mean? Site Reliability Engineer. And I'd like you to take the S is for site, not system. It has a greater scope than most people think. But really, I don't want to bore you with one slide, the presentation slide. I like to take examples from other industries, from the aeronautics industry, for example. And when we think about the aeronautics industry, at least I think about the Concorde. I think about Amelia Earhart's adventures. I think about Sully Sullivan, who landed a plane full of passengers in the middle of the Hudson. And we want to be SREs, and we get the book, the Google book of SRE. We take it as the Bible, and we see, wow, those guys, we want to be superheroes like Google, all right? And but we kind of feel small, no? And I have to tell you something. These guys were bones and flesh like us, and that we can do the same things. So let me take you to a time where the flying boat was the master of the skies. At that time, traveling was a luxurious thing. You know, Pan American was flying the Clipper services, and they did transatlantic and trans-Pacific flights. And of course, the planes at that time didn't have the autonomy to go very far. So doing these trips was kind of a multi-stage journey. They would have to get from San Francisco to Auckland, they had to do multiple stops. And let's accompany one of these crews. While they were flying from San Francisco to Auckland, they found themselves going from Nomia to Auckland, the last stretch of their flight, and the radio signal came in from Honolulu. They had just attacked Pearl Harbor. And the captain goes and looks and says, wow, that's our return route. And luckily, the captain had an envelope in his jacket that said Plan A. Took the envelope out and started to read the contents only for the captain in case of, well, basically it said that it was the plan in case of the war breaking out. And Pan Am had already done negotiations with the army to put the planes at the disposition of the U.S. Army. So basically, the letter came to say the important part is, in the event that you are required to open and read these instructions, you may assume that hostilities have already occurred and that the aircraft under your command represents a strategic military resource which must be protected and secure from falling into the enemy's hands. Okay? So great, now they have an objective. And we as SREs, what's our objective? And I really like this comic strip, XKCD. You see a guy holding a gun and talking on the phone to what is his boss. No, and he's saying, yeah, we took the hostages. No, we secured the building. We cut the communication lines, just as you said. And the boss says, excellent. Continues talking. Yeah, but then this guy came out of nowhere, started climbing through ventilation ducts, going through glass and killing everyone, and we couldn't stop him. And the boss is like, ooh, and he rescued the hostages? Nope. He just ignored them. He reconnected the cables and went off muttering something about uptime. Oh, my servers. Shit. We're dealing with a sysadmin. So that's basically the mission of an SRE. Keep it running. No? Preferably while it's running, so no one takes notice of it. So we're used to thinking about the typical sysadmin as a guy that's running our servers in the data center, changing disks, attending alerts, and wait a minute, I'm talking about SREs. So am I going to say that SREs are just sysadmins? Maybe they're just an evolution of the sysadmin. An SRE, for me, in my opinion, is a sysadmin on steroids. No, they instead of taking the reactive approach to something breaks and let's fix it, and all their time is spent in that fashion, they try to automate stuff. And a good, healthy SRE, they say, should dedicate like 50% of time to reactive tasks and 50% of time to automation. Back to our flight. The thing is that these guys finally arrived to Auckland, and they were there just in the island awaiting orders until orders finally arrived, saying, no normal return route cancelled. Proceed as follows. Strip all companies' registration numbers and identifiable insignia from exterior surfaces. Proceed westbound, soonest your discretion, to avoid hostilities and deliver the plane to New York. Good luck. So yeah, a team is formed. They have to fly from Auckland, and you know, one of these planes, a Boeing 314, you can't fly it with just one person or one type of person. You have pilots, you need radio engineers, you need a guy that looks at the maps, a navigation specialist even, to fly it. So when you're building an SRE team or you're starting to go into the DevOps practices, think about your team. If your team is only comprised by developers, and there's no security experts, there's no infrastructure experts, you'll end up with a solution that's very good for developers, but maybe is lacking on the security side. And if you have a team full of security experts and no developers, maybe your developers are not going to be very happy with the final solution. So there's a balance in your team. Also, these guys, did I tell you that they didn't have any maps? Because they were the other way. They had maps to go this way, no, but not the other way. So they had to find something, and they had to go to the public library there in Auckland and ask for atlases to plan their journey. And in IT, I I find myself sometimes thinking about maps. Have you ever heard of a network area diagram sysadmins used to make them? It's basically a representation of your network. But the thing is that I think network area diagrams, as soon as they're done, they look something like this. No, you start out very detailed, and as you're growing and things change, you start adding things. Ooh, the map is starting to lose precision. Things change. Here be dragons. I didn't update the map, so the state of the map is drifting from what is your current infrastructure. And in the SRE business, since we focus heavily on automation, we have a thing called infrastructure as code. And it's basically that you can represent in code. I wouldn't call it code, I would call it configuration files, but okay, it's code because you version it also. And that's your map. It's always up to date. You need to ask questions about your infrastructure. Go to the repositories and answer your questions. So you don't have that drift, and you also have an automated way of keeping that documentation up to date. So also more things that these guys had to take care about. They were going to do a long route, and they needed spare parts. So basically they started gathering all the spare parts that they could. Of course, there's some type of budget in here. You can't take everything you get because the plane can't fly if you put on too much weight. And also they started stripping off the insignias. As you can see, these planes were painted with quite some American flags. And the order said, strip off the insignias. And of course, as they're doing all of this, new orders come in. And they say, go back to Nomia, there's some Pan Am personnel there. Please go to recover them. And sometimes these things happen, you know, you have your perfect plan. Looks something like this. And you're trying to make it happen, no? But you're very worried about going other ways. And I think that in the SRE business, plans are okay to have. They are needed. You have to know where you're going, but you have to be flexible in their execution. You can't wait to have the perfect solution to put stuff into production. So, and these guys had to take these compromises too. It was do I finish stripping off all the insignias? And you know, the war is advancing, and we don't know where we'll be flying, if we'll be flying in enemy territory or not. We have to go now. So time to market is important. Think about this as an SRE. Try not to be a bottleneck for deploying solutions. And of course, finally, they just took off and started to fly to Gladstone, to Australia, just to find that in Gladstone, there was no 100 octane fuel. The thing is that these planes ran on special fuel, 100 octanes. This was basically, at the time, for only military purposes. So, yeah, and Pan Am bases had plenty of 100 octane fuel, but they were flying a route that Pan Am didn't fly. So they would basically have to run with whatever they found. But the thing is that that plane isn't designed to fly on that type of fuel. So they had to make a calculation and say, okay, no gas, let's go on to Darwin, and once we get to Darwin, we'll see what happens. When they got to Darwin, luckily there was 100 octane gas for them. Problem. there was no automated way to pump the gas into the plane. So they basically had to fill the plane with jerry cans. And of course, as SREs, we're like, no, we should automate everything. No, and this is the philosophy of an SRE. Automate. But I want you to take a look at this. So normally when you do an automation, it starts like this in your mind. Let's build something. We have a task that takes some time. We start writing code while we're doing the task, and as the automation kicks in, we have free time. Yay! Reality tends to say that this happens. You have the same amount of work, and while you're writing code and you're changing, you're still having to do the task and blah, 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 and soon you don't have free time. There are ways to avoid this. Think of delivering small pieces of value another time. Don't wait for the perfect system or try to make compromises in getting things working. Also, how much time can I spend automating things? And this is like a rough guesstimate. If we put on a chart the amount of time, the number of times we do a task, if we do it daily, weekly, monthly, and on another axis, the amount of time that we'll shave off of the task automating it, we can try and calculate how much time we have to work on the automation. And for example, for something that you're working on monthly and you will shave off 1 hour of time, you have approximately 2 days to work on the automation. Of course, there are other possibilities. Think about them the next time you want to automate. So, yeah, of course, these guys couldn't build their own pump, so they had to fill with the jerry cans and finally take off again and start flying, going to Surabaya. Yeah, while going to Surabaya, they were almost shot down by Dutch allied fighters. They landed in a bay full of mines, and the captain said that basically they hadn't shot them down because they saw a flag painted on an American flag and said, oh, okay, they're allies. So that saved them. Oof. Also, yeah, Surabaya, great. But when they're there, no 100 octane gas again. And there's only automotive gas. So they had to take the decision to, let's go with automotive gas if it's the only thing we have. So they pumped all the 100 octane into other deposits and filled up with 90 octane. But the thing is, why could they do this? The plane was not designed to run with 100 octane gas. And I'll tell you what, they knew their machine. So they knew how the engines worked. They knew how it was designed. And so, and this is one thing that SREs have to take into account. We can't, we're building abstraction on top of abstraction, on top of abstraction. We have to know how things work underneath because they're still there. If we know what's happening at an OS level, at the operating system, even if we have Kubernetes is running on an operating system. The more we know about what we're running on and how it works will help us in the long run to diagnose problems or to run in cases no one had previewed. Also, I tell you to watch out for that additional complexity. Sometimes we think that some abstraction layer will really take care of everything, and sometimes it's not that way. So we have to take a balance of this, and at least as an SRE team, we have to dedicate time to understand what it is, and if it can provide value, it's no problem. But we have to think underneath how we are going to keep it running, how we're going to diagnose it when it's broken. So you have to do a balancing act on if you're going to go fully cutting edge or better understood technology. And I think there's a spectrum. You don't want to go cutting edge on absolutely everything. You can have your old relational database, reliable, which you understand, running, and have machine learning on another part of your platform. There's no problem. So think about that. Also, as they're so they start flying with the 90 octane gas. They use the 100 octane to take off because that's when you need power, and start pumping in 90 octane into the engines, and the engines didn't like that. So they started backfiring, they started overheating, and they had to do a careful balancing act to keep the plane flying. Also, since they didn't have good charts, they had to start to fly low to localize terrain. So they kind of saw a whale around there, and oops, it wasn't a whale, it was a submarine, and it was an enemy submarine. And they noticed that because there was guys going for their arms and trying to shoot them down. So full power and try to go up to not be shut down. They arrived to Tricolami. They were received by the British, everything's okay. They filled up the plane, they take off again. And while they were flying, boom, an engine blew up. So they had to return to Tricolami to fix the engine. And if they were here in this conference, they would be saying, what can you guys do? What technology do you have to better my situation? You guys have servers, and I see you guys that when you bring a server on, you give it a cuddly name, and you tell it to do tricks. So you show it to do tricks, installing all the software and blah, blah, blah. But eventually, as my engine, the thing dies. And surprise, in the cloud and the containers world, we have solutions where we can just put a new one in, and infrastructures auto-heal themselves. One dies, you put another one in. And the thing is that as an SRE, you have to help your developers understand this and design for this, because they won't produce naturally these types of solutions. Also, we're thinking about deploying and continuous deployment, and as SREs, we want that the value that people have produced in code get to production as early as possible. And of course, developers, what they want is their shiny new code, the last version, in production. But the problem that the last version has is that it's not as tested in lots of situations. So even if you have automatic testing, which I recommend you do, because if not, you'll basically be shipping broken code around. But even then, when load starts to, sometimes you have situations where you haven't previewed something, and the cloud and container technology lets us switch on an older version. And sometimes even in extreme situations, we can have located a version that isn't the new shiny one, but at least does the job. And then when everything is fixed, we can go for the last version again. Returning to our flight, these guys arrived to Khartoum. They had 100 octane gas again. They gave them maps. They started to take off, and as they're taking off, boom, they lose an exhaust stack of one of their engines, but they say, yeah, we really don't have spares, so let's fly on. What we'll do to this is we'll try to monitor that engine. So they sent up to the observation deck to someone to monitor. And as SREs, we monitor infrastructure too, right? And the thing about monitoring, and the take we have to have about monitoring is that it's okay to collect lots of data, but don't alert on everything. Because if you're constantly saying, oh, this condition has happened, oh, but it means nothing to me. So I've seen lots of monitoring systems that are constantly delivering alerts. And what do operations do with that? Delete, 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 delete. That's it. Cancel, shut up. You're not providing value. So as much data as you want, but alert only on things that mean something to you and which you can effectively actuate on. So, and of course, all your checks won't point to the exact solution. They will point to symptoms. You won't have a monitoring system saying, this is what's failing. No, it'll say, oh, I'm low on disk, for example. And us as SREs have to think, what can make this run low on disk? So we get to play house. Have you seen house? They come up with a lot of hypotheses. No, you have a symptom, and you make a list of hypotheses. What could it be? And when you have lots of hypotheses, what you have to try to do is take one and say, oh, what other symptoms does it have? And try to confirm them. And do this feedback loop. And as SREs, we have to do that. And speaking of the hypothesis, if you're in the middle of Europe and you're here, what's more, the probability is that you're hearing a horse and not a zebra, which makes the same sound. And this in medicinal terms is also something that they study. When we learn something new, we tend to think about that. So take care of that. Also, so these guys went up to Leopoldville in the Congo. They filled up with 100-octane gas, knowing that they had to go all the way to Natal to cross the Atlantic in one flight. The plane was rated for 3,600 miles, and they had to fly 3,480. And that's very, very, very on the limit of what the plane could do. So any error, and since they filled up so much, they started taking off, engines to 100% power. 60 seconds pass, the plane hardly lifts off. They're going full throttle, the plane is hardly inching. They go over a waterfall, they lose the ground, the plane loses the ground effect, so they fall into a canyon. But don't worry, the plane is flying. The pilot looking at the engine indicators, because they're arriving to the maximum capacity. He looks up, there's a wall. And he starts to move, and the plane doesn't turn. And remember about knowing the machine? What the pilot did? No? Canyon. What the pilot did was basically do a handbrake turn. He took the rudder and started to steer with the rudder. And this is because he knew the machine. And I have to tell you something from the aviation industry. These guys are not supermen. These guys practice a lot. When a pilot lands a plane with crosswinds, it's not the first time he's doing it. He's practiced a lot. And as SREs, we have the tools to do this also. we can build, since we have automated infrastructure, we can build infrastructure and start to inject faults into it and make our developers or our SRE team try to diagnose and learn about how, when we inject faults or when faults happen, how the systems behave. And those are called game days. That's something that we can do, and that will make our systems more reliable. Finally, I can't tell you more about the voyage. They basically got to New York. The transatlantic flight from Leopoldville to Natal was 23 hours 35 minutes, and that was a record for the Boeing 314. This was the first commercial plane to navigate the globe. I hope your application circumnavigates the globe too with these tips and tricks. Thank you.
Any questions?
For questions, I'll be over there since we're over. So, or we have time? Yeah.
Yeah. Thanks, José Luís. Just for context of the room, as Microsoft employee, I've worked with Capside, so I know in detail how advanced your SRE practices are. And you had a tagline which said, "We make the world more reliable," if I'm not mistaken.
Yes.
All about reliability.
Yes.
Right? A question that has been done here today, earlier, is about dev and ops and DevOps and SRE and. So how do you see? Are they the same thing? Are they different things? Do they collaborate?
I think it's something that goes into combination. SRE is not confronted with DevOps. It's something that complements DevOps. So as sysadmins, we're the operation team also. So working with our developers and providing solutions for them is one part of the job, and you could call that DevOps. So I really don't think it's choose one or the other. It's the way we approach the problems and more the operational tasks, because sometimes in DevOps we're like thinking, yeah, the developers can run their infrastructure, and we think that operations is easy or that anyone can do it. And the thing is that anyone can do it, but you have to have a set of skills to do it. And those are the SRE skills. So you can teach your developers to have them, or you can have an SRE team